So today I'm going to talk about the Debugging Go application, and with focus more how I can debug Go application running on Kubernetes environment. So let me introduce myself. My name is Alexei Ledenev. I'm maintainer and core developer of open source project called Pumbaa. It's a chaos testing tool for Docker containers and network emulation for Docker containers written in Go. And you are welcome, all beginners who wants to contribute to open source. I have several issues there that help needed. So if you would like to help me, please do. I started with Go 4 years ago, and writing a microservice application running in Docker container environments, and for the last 2 years working also with Kubernetes. You are welcome to contact me by my Twitter, Alexei Led, and also I post from time to time. I publish a post on Medium under the same name. So a small survey. How many of you are using Docker today in production? Oh, pretty much. And how many of you are familiar with Kubernetes and work with Kubernetes? Okay, kind of half an audience. So we'll do a short Kubernetes recap for other half. And so Kubernetes, well, what is Kubernetes? Kubernetes is a container orchestration platform. Actually, and what is a container orchestration? It's when do you need it? When you need to run all your containers at scale, when you have multiple interconnected container running across multiple machines, and you would like to get it with to do it with high resilience. The Kubernetes platform naturally supports a microservice architecture by providing a lot of services around service discovery, auto-scaling, load balancing, security. It's an open source project initially developed by Google and contributed to Cloud Native Foundation. Currently it's under Cloud Native Foundation, a lot of contributors, a lot of tools around it. But the universe of the Kubernetes is kind of more complex than the plain Docker container. So it contains additional objects. You have pods. It's a basic unit, actually something that has an IP. And it can host single containerized application or container and volume, and multiple containers, multiple volumes sharing the same network namespace, same IP. When you can run this pod in multiple replicas, multiple copies of the same pod distributed across multiple machines. So in something that is called, previously was called replica set, now it's called deployment. So you can define the deployment where it defines your pod and number of replicas you would like to have. And you can define additional resource called service. Actually, it's like kind of a load balancer before your pod, so you can single endpoint you can contact and get to your service. And of course a lot of other resources related to security, things like secrets, things like config maps, configuration maps, policies, volumes, jobs, things that runs once or periodically like cron jobs, and full RBAC role-based access rules, and everything defined in YAML files that you are using to deploy your application. And actually, let's remember that your application runs within the container. It's only one small piece inside one of these resources, okay? So, for example, this one YAML file for a deployment. It's kind of long. Each one is quite long. You defined a lot of things. Where a container is only, few lines of code saying, this is my Docker image I would like to run, this is the command, and some command line parameters. Other stuff for limits, for resource allocation, for permissions, for other things. Okay. Let's take a look at the Kubernetes topology. What are main machines or nodes that Kubernetes is running on? So we have a Kubernetes master and a worker node. Okay, so master, actually you can usually have more than one master running API server, the way you are talking with Kubernetes when you would like to control Kubernetes and deploy your application. A scheduler that actually distributed the workload of containerized application across the worker nodes. And etcd, it's storage, distributed storage to store the state of the Kubernetes application. Actually, Kubernetes, you can think about it as a state machine. You define the desired state, and Kubernetes cluster tries to get to this state and maintain it over time. Worker nodes is a more simple one. You run the pod that hosts actual containers, and you have a networking across multiple machines. So each container each pod can communicate with other containers with other pods, and your containers are scheduled by scheduler randomly according to schedule policy. So it can move containers from machine to machine, from pod to pod. And you have a little control where it runs and how many replicas it runs. Okay, if you define auto-scale rules, so it's up to Kubernetes to decide. Little step back. So we are developing Go application, okay, and we would like to debug Go application that runs in container on Kubernetes cluster. So at the beginning, when I started with Go, there was no any kind of debugger, and was accepted opinion in community. People consider that Go doesn't need to debug. You can use printf. It's just fine. Remind me old C days, you know. But actually, there's a lot of people start to use printf and logs is a good thing. Okay, you should use logs. Okay, you kind of try to replace a debugger with logs. And of course, it's better to use structured logs, since it's pretty formatted. You can have multiple log levels. You can have an info and debug level log and error level log. It's better also to include things like stack trace. So the package I'm using, it's logras, and it can be extended, and usually I add also a stack trace, both for debug message and for error message. It's also convenient to define, to enable switching log level dynamically without restarting the process. If you define a signal handling and send the process, for example, some kind of signal, Linux signal like SIG-USR1, I use SIG-USR1 usually, to toggle between verbose log and info log, so without restarting the process. And when you have your application running on cluster, so you have tools like kubectl logs, which allows you to get logs from specific pod and container, and tools like Kale and Stern that can be used to get logs from multiple containers. Okay, so log is good, so use it, but for debug purpose, it's maybe not the best case. So it requires, if you would like to debug with logs, it requires to add lots of log statement into your code. Sometimes people don't agree in the team what log level to use. If it should be log message should be debug level or info level, it's not uniform. And sometimes there are places that are missing logs. So if some place don't have a log statement, actually, in order to debug, you need to add log statement, recompile your application, redeploy it, and that's you have a log. And of course, you need a good log search utility to search within these logs files. Then, the first debugger that supported Go was a GNU debugger, GDB. It's used for C, C++ debugging and other tools, and kind of I try to use it. I know there are people that like it. I say it works, okay? It works. If it's a enjoyable experience, I would not say so. And then we have Delph. It's already in production level. It's version 1.1, I believe. It's actually a fully featured debugger. It's integrated with the most popular IDE today. It's with Visual Studio Code and Golang. It also has for GDB guys, it also have a DLV interactive mode. If you like interactive mode, you can use interactive. And it has a server mode when you can run a Delph server and Delph client. And server provide a JSON RPC API, so it's possible to to connect to remote machine running Delph debugger and debug application running remotely. This is what I will use here, but also I believe the most plugin from IDE also work with this way. And let's take a look at a typical development flow of a Kubernetes application. Okay, one service. So I take the extreme, kind of popular buzzword, GitOps. So GitOps, you start with committing code to Git, and then you have a CI. CI is running is building your code, running unit test, package the final output as a Docker container. So it's doing a Docker build, what's called Docker build, and pushing this to the registry. Okay, but actually the Docker container is not enough to deploy the application. So the next thing to do is you need to update your configuration, your Kubernetes configuration. It can be done automatically with some effort, or it can be done manually, okay? When you update your configuration file, these long YAML files, you put their new Docker image with new tab, you push this again to Git that hosts the configuration, and then you have deployment procedures that trigger by Git commit, Git push. It knows how to deploy your application as a deployment, as a service to Kubernetes cluster, okay? This is the flow you code after you change. This the whole flow that it takes to code to get to the production. So what are approaches to debug this kind of application, this kind of service deployed on Kubernetes, okay? We have two extreme approaches and something in the middle. So one approach is 100% local development. Then you try to develop everything locally. You can use Docker and some mixture of Docker and local processes, or Kubernetes in Docker. There's a project that allows you to run Kubernetes within Docker. Some people are choosing to use Minikube, kind of mini Kubernetes deployed on single machine. If you are using Docker for Mac or Docker for Windows, actually I know about Docker for Mac, it has built-in Kubernetes, so you can spin off Kubernetes cluster on Docker for Mac. And some people use Compose, just try to replicate everything within Compose. So what is the problem with local approach? It's hard to replicate real application, real environment, since you need to have all environment variables and all secrets and the DNS configuration in place. And if your application, usually it's not fully isolated, it also speaks with different services. Some of them are cloud services, so you need access to this. And things like volumes that should be mounted and volumes with data, so it's very hard to replicate. Running also local Kubernetes can be really non-practical. It works very nice for small application, and in my case, for my demo, it would work very nice. But for real application, it's very resource expensive. You need to run tens or hundreds of containers on your local development machine just to develop one single service. It's kind of too much. Okay, and taking Docker Compose, I've been there. It's not advised. Okay, so it's dead end. You will finish maintaining two runtime environments, and which are totally different and not similar at all to what you have in production testing or staging. So 100% remote. It's easy. You have Kubernetes running somewhere on cloud, like Google, Amazon, or Azure, or maybe your own data center. But the issues are that your application run on a remote machine, so somehow you need to get there. Okay. Any code change you are doing to your code, you modify your code, the full life cycle that I showed you before, the GitOps lifecycle, is required to deploy this code to the environment. Okay, it takes time. Also consider that usually the binary, if we are talking about Go, the binary inside the container is compiler optimized. It doesn't contain a debug symbol, so somehow you need to get this information to your binary, and somehow you also need to run debugger in the cluster. So you should consider all these things. So comparing both solutions, so in terms of realism, how similar these solutions are to the real environment. So for local, it's almost not similar at all. It's low similarity. Remote, it's actually the real environment. Okay. Feedback, locally you get a fast feedback. You just spin off your process, spin off debugger, you are done. You're there. Kubernetes remote development, you need to push your change through the whole life cycle to deploy application to cluster and somehow to connect to the container. In terms of resource footprint on the local machine, so it's very heavy when you try to develop or reproduce the whole environment locally. And remote, you have a light footprint of single service running on your machine, trying to connect to remote debugger, mostly. So what is let's zoom into remote development. First of all, you need to modify the image you are building, okay? So you're building the Docker image, you select the base, you're starting from base. For Go, it can be Scratch, actually not zero image or Alpine, or Golang since we are going to put there some information, some code. Then you are building your Go application. Make sure you build it with two flags, disabling compiler optimization and disabling code function inlining. Okay, two flags like -n, -l, actually simplifies the debugger. Then copy the Delve binary into your container, either from builder image or from using Go get. Install it into your container. Expose the debugger port. Select port you would like to expose as a core debugger port. And modify the default command that runs within your container instead of the application. It should be DLV, and then running in serverless mode, headless mode, with port linked to the port and running the application. Okay. Then you go through this life cycle. You push your code, you build the image, push it to the Docker registry, but it's not all. Right now we need to update the Kubernetes deployment. Okay, so Kubernetes have a nice command page. You need to using page command to update existing deployment or redeploy your application with new image. You need to put a new image with new tag. Let's say it's debug tag. And also add some capabilities. In our case, it's recommended to add sys-ptrace capabilities to the container. Then you do port forwarding, sending the traffic from Delve remote port to the local host. And you can start debug your application. And don't forget to roll back everything back after you finish your debug session. So let's try to run the live demo, how it works, so you have a feeling and don't just what I'm telling you. So first, let's imagine I've made a change to my application. I'm not doing it right now since it will take some time. And I will show you the application. Sorry, I don't see anything. So this is my application. It's a simple to-do list. There you can add a task or delete a task. Behind the scene, what I have, I'll try. I'll try to increase the, yeah. What I have multiple pods. Actually, application is using Redis as a database server. So I have Redis master, cluster of Redis master and 2 slaves. 3 replicas of pod. Actually, the Go code deployed as 3 replicas. And 1 service as a load balancer service. Actually, the application is running on EKS Amazon Kubernetes cluster. Then you have a deployment and replica set, everything. And this is my public address to the application load balancer. Okay, so let's start this process. I modify the code, so I need to build it. I'm replicating the CI task. I'm doing I'm running Docker build, so I need to build the process. And let's take a look at the Docker file itself. So I have a special Docker file for debugger. It's a different one from the application. It has Delph installed. Okay, this line. I'll increase it a bit. It also, what I said, it's exposed debugger port, and it also has a command running Delph debugger in a headless mode. Okay, this is the Docker image I've built. So you see I have 2 images. One is a basic application image. It's 18 megabytes, and one is 50 megabytes is a debugger image. The same one with the debugger installed in debug information. So I need to push it. Actually, since I have not changed anything, it should be pretty fast. But in reality, it will take time. And then I have to go and patch my Kubernetes deployment. So there are several approaches how you can patch your Kubernetes application. And Kubernetes supports several patch strategies. One I'm using here, I actually will use 2. The first one is called JSON patch. Okay, it's you can think about it as a commands I give to the JSON parser command and place. So I'm saying, for example, operation is replace. Go to the specific path and replace number of replica to 1. I would like to have a single pod instance instead of 3 pods. I also go in and replacing image with my debug image. Adding a port for debugging, and here the add debug port, adding a sys trace capabilities, and some additional stuff. So I make it bigger. So the command is patch deploy. I'm patching deployment of Kubernetes with JSON strategy, and I'm sending this file I've showed you right now. So it should work, I believe. Okay, it had been patched. Let's take a look. Right now, I should see only a single pod of application is running. It's actually running a debugger, so and I can connect to it. Okay, in order to connect, I need to bring the debugger port to the local machine. So I'm using port forward command and specifying the port I would like to forward traffic from to my local machine. Okay, I'm forwarding traffic to my local machine, and right now I can go and debug the application. So let's try to debug it. Because if it's a remote debug, it will take time to connect. So you see, I already stopped at the first breakpoint here at reading configuration files. It takes time till it brings all variables. So, and then I can go through the code and I can invoke some method. Let's say I would like to invoke method read to do tasks. Behind the application there is a REST API, so-called REST API. Something didn't work as, yeah, okay. It stopped here, okay, and right now I'll stop the debugger. It takes time, it's a little bit slow, and let's continue, yeah. After I finish the debugging, I need to stop port forward, and I need to restore the page I've done to application, actually to restore the original image. Again, I'm using page command, but right now I'm using merge strategy, is a different one, and I use original deployment configuration YAML, the long file that describes the whole deployment with original container and everything. And let's take a look that it comes back. Actually, you can see that there are 4 containers of application is running, 3 are new containers just created. And after they will be in state ready, the old one will go away, the old one with the debugger. Okay, and I can even call a method to see that it works. Yeah, it works. It actually brings me the list of to-do tasks. So I'm back to the presentation. Actually, this is our list of commands I've used. It's inside the presentation, so when I share the presentation, you can take a look. Okay. And also the code itself is also available on GitHub. Can we do better than this experience? Okay, it works. I show you you can work with this approach, making it 100% remote, and if you need, you can get to the remote server and debug your application. But I believe there is a better way. Okay, so I would like to have a kind of local experience with application running remotely. Okay. I would like to have a single service running on my local machine, local development machine, connected to debugger, actually without running it at any container, okay, just single process running in debug mode. But I would like to have the whole environment of Kubernetes cluster with environment variables and the network and the volumes and everything. Okay, and luckily I found the project called Telepresence. It's a Datawire project. Kudos to Datawire. It allows you to debug any Kubernetes service locally using your favorite debug tools. Actually, get instant feedback. Of course, it's any change you do, you don't need to commit it to CI and build a Docker image and modify deployment and patching Kubernetes and all this thing I've done. Okay. You get a realistic environment, since you're developing in a real Kubernetes cluster, okay? And it can be, you can even debug your production cluster. I don't recommend it, but actually you can. Minimal resource footprint, actually. Only your single service you are debugging run on a local machine, and all other services and cloud services on remote. Minimal, and use your own tools. Since it's your own machines, use your own shell, debugger tools, profile tools, whatever you need. And it's the project itself is in sandbox. It's a sandbox project of Cloud Native Compute Foundation, meaning there is a community around this project. It has a lot of contributors besides the Datawire, and it has a chance to become a Cloud Native Compute Foundation project. Okay, it's not yet. So. Let's take a look at the telepresence, how it looks like. So back to terminal. What I'm going to do, I'm going to run, I'm using telepresence. I will explain later how it works. But actually, currently I will get a shell, Z shell. This is my shell I'm using. I could get a bash or whatever, into the namespace of my application. Okay. It behind the scene actually it creates a connection. It does require root permission on your laptop, but actually behind the scene it deploys the telepresence pod on the cluster into my namespace, and kind of create connection and create environment for me on my laptop. It will take some time. It's a real demo. In the case it won't work, I have a video, so I can. But I pray to the demo gods that it will work right now. Okay, you think it's tab completed, launching command. And I must have, okay, I have a shell exactly the same, but new instance. It's my shell. How I can, what can I do right with it? I can, let's say, right now I'm inside the cluster, so I can connect to the Redis. Let's see, I'm sending the DNS. I would like to see if I can see the Redis master. So I'm sending dig command, and you see, the server is available. Okay, let's try to connect to the server. It runs on Oregon EKS somewhere out there. Okay, but I'm running Redis CLI here. I'm connecting to the master. Yeah, I'm here. So let's try to get some data. No, it's keys. Yeah, I have a list, to-do list. So I will. And to do, actually the whole database is just a basic list, so I can see all tasks. Nice. I can exit. I can use my command to see what is there. Let's say I see currently the file system of the remote pod. Nothing there. Okay. In this folder specifically. Okay, but I can see that it's running Alpine Linux. Okay, what I've done, I've opened a shell to the remote cluster, to the application namespace. Let's right now try to debug Go application running in already on existing pod. Okay, it will require some change. So let's go to the Visual Studio Code. Run the same telepresence command. It's possible to run debugger immediately from the console. I would like to show it in 2 steps. Actually, I will run a bash shell replacing, you see this command swap deployment, meaning I'm going to replace my application deployment with shell, okay, and sending all traffic that arrives to port 3000 to the local machine. Yeah. Meanwhile, we'll continue. It will take time till it connects, a couple of seconds, so I will explain how telepresence works. Okay, you have a remote Kubernetes cluster, and you have a developer machine. The telepresence command, I'm using command line. Actually, when I use it together with swap deployment command, it replaces the original pod that runs on the Kubernetes cluster, with change it replica to 0, and creates a new pod with the same environment variables and same volumes attached, and some DNS and TCP proxy which is tunnels through kubectl port forward SSH tunnel. Okay, it tunnels back to the local development machine. So any sub-process I will run here will get the same environment variables and same volume available for me. And any sub-process I will run in the shell will actually enjoy from the same environment. Getting back to the application, so I have a bash. I will run delf Currently, I'm running delf locally, okay. And I'm attaching debugger to it. So I'm reading configuration file, and it's come from the mounted telepresence root. So it's a file that comes from the Kubernetes cluster into my local environment. And when I invoke the command against the remote Kubernetes cluster, let's say to-do list, get to-do list from the remote machine. Okay, for some reason it failed. Yeah. Sorry. Okay, it's supposed to work. Currently I'm stopping everything. So I don't have enough time to show it, but I have a video, and one demo worked, the second one did not right now. You're welcome to come to me after the session on the break. I will show how it works. And you can also try it by yourself, doing git clone, and have a readme file how you can reproduce everything, okay? So actually, let's back to the slides. So this command you need to run. Actually, when you're using telepresence, you just need to run to open a shell to remote machine, exposing the port, and start debug and locally, and connect to your code and start debug locally. And any change you do, you can immediately run and check this change against the real environment. So give it a try. It's a great tool. And there is another one interesting project called KubeSquash. It's kind of try to achieve similar, help you to debug Go application running on Kubernetes cluster. Actually, I tried to work with it. I spent 2 hours, but kind of cannot figure out how to make it work. So maybe give it another try later on. And that's all, guys. If you have any questions, 1 minute. Okay.
I actually have two, but the first one is why is it a requirement to include the disable GCC flag for the debugger, as well as to disable inline while debugging?
This is actually not exactly, it's a recommendation from Delph itself. When you run Delph as a headless mode, so they recommend to disable code optimization. So in order to show the appropriate lines of code when you debug.
So it's only for like when the function gets inline,
Yeah.
So that the debugger points to the exact temp.
Yeah, I would like to see exact code line in your code. So.
But it's supposed to work in any case, right?
Yeah, supposed to stop. At least you can stop, but actually, if you'd like to see the code line, it should be there.
The second question is more Kubernetes related.
Yeah.
You mentioned that a very important step is to revert the configuration changes back, the patch you did to revert it. And my question is, what happens if you don't? Is it like screwing up your production environment? Is it mixed up, or?
Actually, I don't recommend to use this approach on production environment. Okay.
No,
so.
But what actually happens if I do not revert?
If you don't revert change, what happens that you will have a Delph debugger running in headless mode, waiting for debug connection to initiate. Your application will not respond. So when you run Delph debugger in headless mode, it actually waits for Delph client to connect. It just kind of freeze. So.
But it will.
It will not execute any code. It's just waiting for. Okay, guys. Thank you. If you have questions, I can take them later.